I'm Jinia Roy. I'm an assistant professor at UW-Madison. My team and I are developing the power management unit, and it is sitting in between the reactor side, the power generation, and the thruster as the load. So we are developing this PPU to drive the thruster, which is pulsating in nature, but the reactor is continuous power. My research focus is power electronics, the control and optimization of power conversion for various applications ranging from pulsed power, space power electronics, and renewables. For the SPAR, we are developing the high power density, and this is not volumetric power density. We are talking about the gravimetric power density, which makes a huge difference when it comes to the space power electronics. So we are optimizing the gravimetric power density and the efficiency of this power conversion. And there are not quite a bit of challenges in there. It's not a conventional way of optimizing or designing the power converters. So some of the instances would be looking back at the magnetic modeling, and start from the basic equations and develop from there for a better design for SPAR, and the filter orders that we are looking into, how we are optimizing the passive components, and not only the magnetics but also the capacitance. And like I said, it's a pulsed thruster. We need to store that energy for some period of time and then release it in the next instance. So storing that energy more efficiently and in a better way is what we are looking into. That's on the power electronics side, but then we cannot do whatever we are doing without the thermal management, and our collaborators are also looking into how can we, so if we have 5% of efficiency loss, or we are targeting 95% efficiency, so that 5%, how do we better dissipate them so that it does not increase the mass of the system as much, and so it is more of electro-thermal co-optimized design for SPAR efforts. So we have used the first year to develop each of the components in the PPU system, and the next year we are going to look into the higher power levels, higher voltages. We do have the first prototypes. Now we are iterating for higher voltages, higher power, and by end of year 2, quarter 3, we will have a working model with closed loop systems, and also the thrusters models integrated, so that we can we are prepared to connect it to the thruster come quarter 4 next year, and we can see our PPU driving the thruster as part of year 2 plan. We are looking into the next generation power management unit design, which is best in terms of efficiency as well as the gravimetric power density, which has often been neglected in the conventional power electronics design. And we are doing it by co-optimizing the thermal as well as the electrical design, and if we are successful and we have this PPU working, it can be the enabler for many other technologies in the space domain.